Welcome to another conceptual lesson, abstraction. There won't be any code in this lesson. Instead, we'll discuss an object-oriented programming concept called abstraction, which improves the readability and maintainability of your code. Let me explain what abstraction is using our ice cream example. This is our slide from before. Notice we've outlined the expectations of any ice cream instance we encounter. For any ice cream instance, we know what the ice cream instance does and what data each ice cream instance has. For example, we can eat an ice cream instance, but more importantly, we can eat an ice cream instance without knowing how the eat method is implemented. The last part is key. As a user of ice cream instances, we can abstract away and ignore how these methods work. We just need a rough description of what the method does. We call this notion of abstracting away details abstraction. To repeat that definition more succinctly, the idea of abstraction is to remove unnecessary details for the user. In our example, the user is the ice cream eater. The person eating knows they can eat the ice cream or add scoops. The unnecessary details, how the ice cream handles eating, are abstracted away. This improves the readability of your code. We're now going to discuss what abstraction is hiding away. What is this unnecessary information? This next section exemplifies a related concept called encapsulation. In the center, we have our two methods, eat and add. On the right, in blue, we have method descriptions for external users. The eat method allows users to eat until no more ice cream is left. The add method allows external users to add more ice cream. On the left in red, we have the internal workings of each method. Internally, we maintain a count for the number of scoops left. Not too surprisingly, eat simply subtracts a scoop, and add simply adds a scoop. The red internal details are hidden away from external users. To enforce this, we use encapsulation. We won't emphasize encapsulation too much. Just know that encapsulation involves restricting access to internal information, like enforcing that scoops cannot be modified by outsiders. In sum, encapsulation hides information from the user. If you're confused about the difference between abstraction and encapsulation, that's okay. Not knowing the difference, even after completing this course, is okay. Using abstraction and encapsulation, whichever one it is the important part. Now we'll discuss a benefit of abstraction, which is to remove redundancy in code. This redundancy removal is how abstraction actually improves maintainability of your code. Here's how abstraction removes redundancy. On the right, we have an ice cream cone. It supports the add method, which adds a scoop of ice cream. On the left, we have an ice cream truck. It makes sense that when ordering from the ice cream truck, we also add a scoop of ice cream. However, what if we want to modify scoop adding behavior? Now, we can only add a scoop if the total number of scoops is less than 3. We also need to add this restriction wherever we add a scoop of ice cream, like in the ice cream truck. Next, what if we add another modification? If there are no scoops left, add 3 scoops at once. We also need to add this wherever we add a scoop of ice cream, like in the ice cream truck. This quickly becomes a maintenance nightmare. Here's why. What happens when these two copies of scoop adding code go out of sync? Then, the ice cream starts to behave in unexpected ways. You might have some ice cream with more than 3 scoops, for example. These unexpected behaviors are what cause bugs in production, so watch out. But how do we fix this? We only want one copy of the scoop adding code. Quite simply, any code that adds ice cream scoops should call the ice cream class's add method. Nobody else should directly modify the number of scoops in an ice cream cone. Enforcing this abstraction allows us to reduce redundancy in code. Tip: check for redundant code. If you're copy-pasting or writing redundant code, you're doing it wrong. We'll elaborate on why and how when we begin coding. Abstraction removes unnecessary information. For example, you don't need to know how ice cream eating works to call the eat method. This improves the readability of your code, making it easier and quicker to understand. And encapsulation hides or restricts access to information. For example, you can't access the number of ice cream scoops left directly. Finally, abstraction removes redundancy in code, so abstraction also improves maintainability of your code. So, don't forget abstraction. Here's a summary of the concepts we covered so far. For a copy of these slides and more resources, make sure to check out the course website. This concludes our lesson, abstraction. In the next lesson, we'll simulate an ice cream truck that correctly implements abstraction.